so that you know the overall flow on how to build a simple machine learning task. Alright, so in this case, before I start the coding part, I won't focus much on the coding, but instead I will more focusing on the idea, the concept behind. If you don't understand the idea or concept behind, then it will be very hard for you to understand why I do this and do that. Okay, so I want you to look at this slide first. A few slides. So assuming that you have 7 friends, they call Tiana, Diana, Joanna, and Sina, female. Then you have a 3 male called Johnny, Jimmy, and Jackie. So you have only 7 friends. Okay? Huh? Okay, assume that you have only 7 friends until today. Okay. So what if, let's say, today you receive a letter, okay, and this sender called Jaden. Hey dear sir, I'm Jaden, how are you? So if you look at the letter, there's no profile pictures, there's no introduction about what is Jaden. You got no ideas who is Jaden, whether it's a male or female. So based on the friends that you know, can you predict? Can you predict or can you tell me whether Jaden most probably is a male or most probably is a female? Male. Why?
Sounds gay.
Sounds gay. What?
Sounds
similar. But if you based on this case, forget about sounds like, because you know Jaden why is male, because based on your experience, right? You know Jaden sounds like male. But if let's say now until today you have only 7 friends here, and there's a new name called Jaden, can you predict whether Jaden is male or female? Based on this case. Can.
Johnny, Jackie, Jimmy. OJ.
Okay, so you say that, your friend says that because of OJ here, so I can predict Jaden is a male. Okay, what if let's say now you have a name called Corona? So based on this case, whether it is a male or female?
Female.
Virus is a virus. This virus is female or male? Unisex.
Sexual.
Bisexual. Okay. So you say what? Someone say female. Why? Because NA. You see, all of the NA here give you the idea is a female. But we know that we still have some names start with J. They are female. For example, Jenny. But if based on this case, most probably we talk about the probability. The chance that started with J is tendency to is a male, and if your name is N with the NA, tendency is female. Because here we have a J also, but this is the female, but a lot about the probability. Okay, so in this case, we know that J is a very important letter or important features for you to identify whether it's a male or a female, and as well as the last 2 letters. We know the last 2 letters NA is going to give you the hint whether it's a male or female. Alright, so this important information here, we will call this as a feature. This J here is an important feature. This NA is also very important features that help you to decide the gender of a person. Okay, so if you understand this idea, very good. So now, go back to the code. Okay, I hope you can understand this part. Alright, so okay, in machine learning, there is some pipeline, or we call it as a flow that you must follow. The first step, you need a large data set for a machine to learn. Okay, so this data set you can get it from Tagger, or in NLTK itself also, in NLTK or the Scopus, that there are some data set available that already collected by someone and put inside the NLTK. For example, the names. Okay, so you just download the NLTK.download. It means that you, from this library, you download the name data set. Okay, so under this name data set here, you have 2 files. The first one is called male.txt, the second one is called female.txt. It means that inside these names, there are two files here. One is a male, and then one is female. So inside this male name, inside the male.txt, there are about 2,000, yeah, about 2,009 male names. And then inside this female.txt, there are about 5,000 of female names inside the file. Okay, so I did some data exploration here. So it tells me that the data set that available inside the NLTK consists of 2,009 of male name and about 5,000 of female name. You don't have this part because I just added yesterday. Right, and then I can just show that what are the names in the male file and also the female file. So that is the first step. You need to acquire the data set first. So in this case, we have two files. Okay, so this is a txt. So this is a male, and then we have another file which is female.txt. Okay, so this one about 2009 of the name, and then this one is about 5,000. Means that we have a list of names here. Okay, corona or whatever. So this one you have about 3,000 of the data. So this is the first step. You need to acquire the data set. So after that, okay, you look at this chart of code. Okay, so first thing first, we need to import this data set and store inside a variable. I store inside a name. It's a list. So I will store all the name inside this variable called name. So for example, I have an AB, which is a male. Okay, I have an Aaron, which is a male, and so on and so forth. And I have a Jenny maybe. Jenny is a female. So it means that I have about 8,000 of name inside this variable. Okay, clear? So what I will do here is, you still remember that just now you identify that the first letter, the J, is play a very important role to identify the genders, and also the last two letters. Okay, so you will see that in this part here is actually feature extraction. It means that I identify the features. If you feel that, let's say now Jenny. If you feel that the first letter is going to play a very important role, then you're going to extract the first letter. It's called prefix. Okay, then you have to tell the machine, hey, if you look at the first name start with J, it is a female. This is how we teach the machine. If you feel that the first letter is not sufficient for a machine to learn, then you add one more feature. You add prefix 1, and also you add prefix 2. Means that if you start with JE, it is female. So it means that we teach the machine, hey, if you have a name start with J, most probably it's a female. If you have a name start with JE, it is a female. If you feel that this is not sufficient for a machine to know, to learn, then you add more features. You add more features. This is prefix 3. Okay. Wow. Okay. You feel that maybe the first 3 letters are not sufficient. You want to add the last letter, okay, it's called suffix. Suffix 1. You train the models. The more information you give, the more features you give, the smarter is the machine. Now, later on, I want you to try. You just include the first features you want to program. See what is the accuracy. After that, you slowly increase the features. You monitor the accuracy, whether increase or decrease. I want you to test later. But the idea is, illustrate from here. Okay, so this prefix suffix here, I will treat it as a feature for a machine to learn. Okay, so if you feel that it's not sufficient, okay, it's fine. You can add one more suffix 2. Okay, it means that if you will start with J, it's a female. If you start with JE, it is a female. If you start with JEN, it's a female. If you start with NENN, it's a female, and if you start with NNNY, it's a female. So the machine will start to learn. If let's say in future you have a name called Jennifer, it's a new name. So you try to put inside the machine will based on what it had learned, JN, and also JNN or JNN. Then you will predict that Jennifer is actually a female based on what it had learned before. So this is how machine learning works. Is that clear? Not listening, using some song, is it? Check with your girlfriend. Okay, right. So this is the picture extraction. Okay, after you have a data set here, you have to extract the picture. Okay. So next step, what? So next step here, we will extract, right? Okay, like in this case, we will define the features and extract the features. Define and extract. So what is extract in this case? So each of the name here we will extract and tell the machine. So maybe we have another name called AB. So we will extract A here and tell the machine, oh, A is maybe it's a male. Extract the first two letters, AB. So this is a male. Extract the first three letters is a male, and then maybe ABBY is a male. So we will pump in the 8,000 of this data to these features, and then for the machine to learn. Okay. So after that, what? After that, we have to suffer or we will randomize the data. We don't want the data to arrange in such a way you have all male. You have all male for the first 3,000 and then followed by the female. So we want to randomize it. Okay, we have some male, we have some female, maybe we randomize the data. After we randomize the data, so the most important step here is that we have to split this data into the portions 80% to 20% or 70% to 30%. Okay, it means that now we have 8,000 data, right? We have 8,000 data. So we are going to split, if we use this 80-20, means that from 8,000, we are going to split 80%, we will get about 6,400 samples. We have 8,000 samples now. We take out 80%, we will get about 6,400 samples, and the remaining 20 samples will be 1,600 samples. So what we will do with this sample here? So this 6,400 here, we will call it as training samples. And this 1,006 we call it as testing sample. So what is the difference between training and testing? Training means we are going to pump this data to the algorithm or the machine to learn. Okay, we will take only 6,004, put inside the algorithm and learn. So for example, okay, you have a J, so this is a female. You have a JE, it's a female. You have a JEN, it's a female. JENN is a female. You have an A, it's a male. So only 6,400 samples we will put inside this algorithm for the machine to learn. So the machine will start to find a pattern. Or you have this A is a male or not, it's a female, or so you start to learn. So how it learns, we don't care. We let the machine to learn. Okay, the algorithms, whatever, we will cover in chapter 7 machine learning. Okay, at this moment, you just assume that this algorithm is just a function. The functions will learn by themselves. Okay, alright, so after it learns, what happens? After it learns, then we will go through another process to assess the performance. After you train the models, we don't know whether this model is good or not. Okay, it's smart or not, we don't know. So what we'll do here is assume that this is the algorithm that you already built. Okay, it's already built. You already trained the models. What happened here? We will recycle these 6,400 samples here. Okay, we will pump again this 6,400 without the label. Without the label means that you just pump in the J, JE, JEN, okay, without the label, which is the machine doesn't know that this is a male or female. You want the machine to predict. Let's say Jenny Jenny. Okay, we pump in, then let the algorithm to predict. If the algorithm predict is a female, and we know that based on the answer here, Jenny, yes, it is a female. That means that it's correct. Okay? Then we will repeat for the remaining 6,399 samples. Okay? Repeat. and then we check the accuracy. Out of 6,400 samples, how many accurate? How many samples that predict accurately by this machine? Okay? Why so happy? This is so-called training accuracy. Training accuracy. Okay, means that we recycle the training samples to test the machine. So the next, we will use the remaining 1,006, perform the same thing. We have 6,004 already. Then we get the training accuracy. So same, we have another 1,600 samples that never seen by the model before. Never seen by the model before. This one we've seen before, right? The model used this one to train, to learn. But this one, no. This is something new for the machine. We want to try again, we want to test again. If you have some unseen data, what will be the accuracy? Then from here you will get this, and you will get testing accuracy. So if both also consistent, it's about more than 75 or maybe above 75, then we will say that, oh, this model is good enough. Huh? Okay, so that's the overall pipeline. So why do we need to separate this 80%, 20% or 70%, 30%? One of the reasons is we would like to avoid this overfitting happens. So what is overfitting is where you overfit the model, you overtrain the models, where the model just memorize everything that you teach, then he lost the ability to make his own decision. Okay, just like I give you the book AI. You study everything, you memorize everything. You memorize the content from the book, study, and then you sit for the exam. If I set the question is from the question, from the book, definitely you can answer very well. But what if let's say I twist the question a little bit, something that you never seen before? If you are not able to answer it correctly, then your testing accuracy will be very low. Okay, so we have to test these two parameters. And to avoid overfitting, we have to split the data into two different portions. We want to avoid the machine from memorizing everything from the reference. We split something and keep some unseen data for the machine to test actually. Okay, so you will see that from here. Okay, I start to. Okay, I download the name. I put inside this name here. I define the features. Let's see here. If I just use one feature, what happens? If I just use one feature, I start to train the model. I run this code. Okay, you'll see that the accuracy, it will show you two parameters, right? One is the training accuracy, one is the testing accuracy. You'll see that one is 76% and the other one is 77%. It's quite good, it's quite good. Okay. So what if let's say now I try to include more features? Just now it's 76 or 77. So I try to run again. Let's see. So just now it's what 76. Now to improve 79%. And then the second one, testing, it improves to 78%. So it means that the more features that you fit to the model, the smarter is the model to do the predictions. Okay. So beside that, you can also use the functions called show most informative features. So this show most informative features, it will tell you that based on what the machine learned, it will tell you that if let's say the name end with the NA, the portions, the ratio between the female and male is about 83 to 1. It means that based on what he had learned, most of the names that end with the NA, they are female. Because out of about 84 people, 83 they are female. And only one is male. Okay? So in your assignment later, I don't want you just stop at the training here. I don't want you just to give me accuracy is 80%, then you stop with that. I want you to further analyze why the accuracy is just stop at 80%. Can you enhance to 85? And what are the possibilities? The accuracy is why low? Is it due to the sample size is not sufficient? Or is it the features that you use are not suitable? Or any other reason? So you can use these functions here, for example, most informative features. Or maybe this one, errors, to find what happens to your data set. So this errors here shows that, okay, so what does it mean by this error? So this error means that in actual case, if you have an error, let's say, error, so it is a male. If let's say the algorithm predict that this is a female, which is not equal to the label here, then it will show you. So this list here, it means that the actual features, the actual label for the AB is male, but however your algorithm predict that it is a female. Then you try to analyze here, then you can identify why the accuracy is very low. And based on this error, is it something that you can improve? Is it more features that you can insert? Okay? So I don't want you to just stop at the accuracy that, but you can further analyze your result using a certain function. Okay, so this naive Bayes is actually a probability base of algorithm using a probability. So you will learn this naive Bayes later. If you don't want to use naive Bayes, you can actually go to this website. You can modify. Okay, so just now we used this classify naive Bayes module here, right? So you can actually use decision tree, right? You can use this one. Okay, just modify, change this decision tree. Okay, and then you can change. Okay, classify decision tree. Then you basically modify or you change different algorithm. But you are using the same data set, but you just change the algorithm name. Okay, so this one I let you to try. You can try different algorithms here, decision tree. One of the famous here is decision tree, right? Naive Bayes, or you can use also the SVM. Okay, so I give you some time to go through. If you don't understand, raise up your hand and ask us. Okay. So I want you to go through, start from the beginning. What's happening here? Okay, what's going on here? What is the features? Try to include more features and compare the accuracy, as well as maybe if you feel that 80% is what happened if I change to 70-30, then you modify the parameters, change to 70%. If you don't trust that 80-20, you can modify to even 10-20, see what happens. Okay, try to explore the parameters, and as well as the so-called the machine learning library. So here I'm going to use a naive Bayes. You can modify using a decision tree. You can use a support vector machine. Okay. So so in these applications, I would like to build some machine learning that can identify the polarity of a lexical. What is polarity? Polarity is means that is this word a negative word or is this a positive word? For example, good, excellent are positive. But how to train the models and tell me that this is positive? This is what they're going to do now. Okay, you want to build a system or build a machine learning model which can identify if you have this word, if you have this extraordinary, then this is considered positive. If you have a word called, like for example, bad, sad, all these are negative. Okay, so how? First step, you need data set. So in this case, I'm going to import a file called movie review. So these movie reviews are actually a document that already compiled by someone and stored inside the NLTK. So this movie reviews is actually a folder. You can search from the Google. It's actually a folder. So inside this folder is called movie review. So this movie review, you have two sub files here. The one is a positive and one is a negative. And each file here you have about 1,000 of txt files. You have about 1,000. Same goes to the negative. You have 1,000 of negative files. So inside each of these files, you have a lot of comment for each of the movie. Okay, so this movie is very bad, blah, 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 blah. So you have this review from people. Okay, and then if you know that this is a positive, we put this inside this folder. So this is your data set. Clear? Okay. So after that, we extract the features. So you can use your own features. In this case, I'm going to use the feature so-called most frequently occurs. Means that I will extract the highest frequency, the top maybe 1000 word that is inside this 2000 file. Then I will assume that this 1000 words are significant, are very important. Let's say good is always, you have these keywords always happen in these two documents, right? Two files. Maybe you have maybe bad, delicious, okay, extremely. So we have 1000 words here. Okay, let's see. So what we'll do here next is we will take this document, each document here. We will do a scanning. Inside this document, do we have these words or not? If yes, list out. Maybe I take out the first document. I have this word, good. And I know that this file is stored inside a positive. Then I will have the first data set. Okay, good, stored inside the positive. Then I will scan the second document. Scan whether I have this the highest frequency words inside this document or not. If yes, what kind of words? Maybe you have this word called extraordinary. It's a positive word. Repeat for the 1000 documents. Same goes to the negative. Start with the negative. Okay, scan. Do we have this 1000 word inside this document or not? Yes. Extract out. Maybe you have this word called bad. It's negative. And so and so. So after that, what we'll do here is repeat the same process. Split the data 80, 20, 70, 30. Train the models. Assess the model. Same part now. Come back to the coding here. Okay, so this is some data export coding here. I have a movie review. So here I have about 2000 files. So I have two folders, one negative and positive. Okay, and each file I have 1000 file, 1000 comments. Okay, so that I will find out which words that is highest frequency, that has the highest frequency. Okay, so these are the words that always shown in the files, in the 2000 file set. Okay, after that I will do a scanning. Okay, I will do a scanning, see whether this document has that word or not. If yes, extract out and identify which label. Is it a positive or negative? Repeat all the 2000 files. I will split the data 80-20. I will do a training. After the training, I test the accuracy. So after you run the code here, what happens? So you will see the accuracy 83% and 77% of test accuracy. At the same time, you can also use a function called most informative features, and it shows you that the worst word here, this word, okay, so it's always happened in these two files here, or positive or negative. And based on what machine learned, it shows that the tendency of this word is a negative is much higher than a positive, based on this ratio. Okay, then from here we know that worst, the machine will tell you that worst is actually a negative comment. Stupid is actually a negative comment. Memorable is actually a positive comment. Boring is a negative comment, and so on and so forth. So from here we can identify whether this word is a negative comment or positive comment. So we let the machine to learn by themselves. You will notice that I don't have any if else statement in any code here. Based on the past, if last being back to the 20-30 years ago, we are going to use this if else statement. If let's say you have a word called worse, then it is a negative. Last time we do like this, but now no. We don't use if else statement anymore. We put the data, we put all the data, we just throw everything into the machine learning, into the algorithm. The algorithm will learn themselves. learn, and make a decision for you whether good is a positive or whether bad is a negative. They make the decision like that itself. We don't have any if else lose anymore in this coding, you see. We let the machine to learn, to find the pattern. Okay? So yeah, so I hope you can digest from these few simple examples.
还有一个写了10个人，他那个文字信息嘛，有限。